All right, let's think about analyzing some series circuits mathematically. So there's some rules we need to know in order to do that. The first one is that amperage in a series circuit is the same everywhere within the circuit. So if I have this loop and I've got I equals 4 amps, then I for intensity equals 4 amperes. I have 4 amps here. Here, 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 here. I have 4 amps everywhere. It doesn't change in a series circuit. It is not variable in a series circuit. So next is voltage in a series circuit is used by the loads in the circuit until it is all used up. That is Kirchoff's voltage law, or KVL, which is saying that this Greek letter epsilon, which means the sum of all the voltages equals 0. So what that means is if I have some voltage here, then I have voltage across R1, voltage across R2, voltage across R3. The original voltage minus VR1 minus VR2 minus VR3 is going to sum to 0. It's going to equal 0. Now, each one of these loads uses voltage in proportion to the value of the load. So if these were all the same, and let's say this was 12 volts, and I used 4 volts here, 4 volts here, and 4 volts here, that would mean that each one of these loads had the same value, the same resistance. But if this one was bigger, say this is 12 volts here, and this is using 6 volts, that means that this resistor has to be bigger than this one or this one. Because if this is using 6 volts all by itself, that means there's only 6 volts available for these two. So the most either one of these could be would be 3 volts or 3 volts, 4 volts, 2 volts, 5 volt, 1 volt. Some combination there, but the most they could ever equal would be 6, because this one's already using 6. So that's Kirchoff's voltage law, and that each load uses voltage in proportion to the value of the load. Now, the total resistance in a series circuit is equal to the sum of all resistors. So to write that out, we'd say R sub T, so R subscript T for total resistance equals R1 plus R2 plus R3. And then we could write this out to reflect that if we had a whole bunch of resistors, we could just continue adding them until we got to R to however many we have. That's what the little n right there stands for. It's some number. So in this case, I have R1, R2, and R3. So to calculate it, it would simply be RT is equal to R1 plus R2 plus R3, whatever those values are. But down here, if I had a circuit, series circuit with a whole bunch of resistors, I'd have R1 plus R2 plus R3 plus R4 plus R5. I add all of those up to get RT. So the resistance in a series circuit is really just a matter of add them up. That's all we got to do in a series circuit. Okay, so we have talked about Ohm's law in the past, and now we're going to be using Ohm's law. Ohm's law equals voltage is equal to current times resistance. And it's a very simple mathematical equation that we can plug numbers into to find unknown values. So right here, if I don't know what V is, okay, but I'm given that I is 2 amps, and I have the values of each one of my R's, okay, each one of my resistors, then finding V is very simple. I've got I already. I've been told it's 2 amps. So now I'm going to use that whole what is the total resistance in a series circuit formula, which is R1 plus R2 plus R3 in this case. RT equals 3 ohms plus 2 ohms plus 1 ohm. And I end up with 6 ohms. Now I just plug those numbers in, all right? I don't know V. That's my unknown. So I do know 2 amps. That's my I. So I'm going to put 2 amps here. And I do know my R. That's my RT value, the total resistance. So I'll write down my 6 ohms here. And that means that V goes to 12 volts. Because I'm multiplying 2 amps times 6 ohms. So that's a very basic and very simple way to use Ohm's law. I can also calculate the voltage drop across each one of these to verify Kirchoff's voltage law. I'll pause that, do that real quick, and then we'll come. So here we are, and we'd already calculated that the voltage in this circuit is 12 volts. But if I wanted to know the voltage each load is using based on these resistance values, then I would calculate VR1, which is voltage across R1, is 2 amps, because remember, it's 2 amps everywhere in a series circuit. The series circuit, amperage doesn't change. And I have 3 ohms. So VR1 is equal to 2 amps times 3 ohms for 6 volts. VR2 is equal to 2 amps times 2 ohms here, and that equals 4 volts. And then VR3 is equal to 2 amps times 1 ohm, which is 2 volts. So then I look at this and I say, all right, I had 12 volts. Now I'm using 6 volts, so that's a negative. And I'm using 4 volts, so that's a negative. And I'm using 2 volts, so that's a negative. And I say 12 minus 6 is 6 minus 4 is 2. 2 minus 2 is 0. So 12 minus 6 minus 4 minus 2 equals 0. And that checks out because remember, KVL says the sum of all of my voltage is equal to 0. Kirchoff's voltage law, that's what it is right there. So we've analyzed this circuit completely. Series circuits are pretty straightforward to analyze. There's not a lot of tricky stuff that goes on in there as long as you have some good starting points.